Hi, my name is Steve French. I'm a member of the Samba team, and I work for Microsoft in Azure Storage, and I'm also a longtime kernel file system maintainer. I'll be talking today about the SMB3.1.1 POSIX Linux extensions. I'll be talking a little bit about the difference between POSIX and Linux, why SMB3.1.1, and what are these extensions and what works. And it's exciting time now because Samba now has support for the SMB3.1.1 POSIX extensions, so we'll have a chance to try them out. I'll also explain about Wireshark status and improving the documentation and where do we go from here. So the POSIX extensions were available on the Linux client as early as the 5.8 kernel, experimentally, back 3 years ago. And they're much improved by the 5.15 kernel released in October of 2021, and they've had some gradual improvements since then. Samba's SMB client tool has also been updated with support for POSIX extensions, and ksmbd has had support for the POSIX extensions for multiple years. Now, there were POSIX extensions in the original CIFS protocol, and that was kind of interesting. But the SMB3 protocol, well, SMB2, then SMB 2.1, SMB3, and then SMB 3.1.1 has long superseded that, and we've had a long need to update these. And it's been really exciting to see the progress recently, especially now that Samba has partial support for the POSIX extensions. And at the Storage Developer Conference in the fall, we were able to test against other servers. Similarly, a few years ago, we were able to test these POSIX extensions against some third-party servers at earlier SMB3.1.1 test events. So the first things first, let's talk about what POSIX means. POSIX created many years ago, that's more than 30 years ago, was based on Unix, and it was later standardized in the late 90s. Now, SMB was created 4 years before POSIX by Dr. Barry Feigenbaum at IBM, and I think some of you may have even got a chance to meet him many, many years ago. So SMB3.1.1 protocol, on the other hand, was created in 2015, and it's been extended multiple times. It's a wonderful protocol with an incredible set of features. It's part of a family of protocols that's quite large. But one thing that confuses many people is they think of POSIX as being the same thing as Linux. Well, POSIX is kind of old, and Linux keeps evolving, and you'll get a chance to see what I mean in a minute. So the Linux API is so much bigger than POSIX was. It's a huge number of syscalls. So I just checked it literally today, and we're now up to 879. That's 18 more syscalls than we had last fall in the Storage Developer Conference. Over 500 are documented. Just try man syscalls. Now, that was only about 100 POSIX API calls, but the file system layer alone of Linux has over 223 syscalls. So Linux API is so much bigger than POSIX and so much more important for modern apps. So I don't want to make it sound like our goal is this thing from 30 years ago. Our goal is to support modern operating systems. So the file system API keeps growing, and to give some examples of this, let's talk about folios, for example. Dave Howells and Matthew Wilcox and others have been adding these changes for these internal APIs to support variable size pages. They've been adding these layers like NetFS and FSCache. I think you'll hear a talk today or yesterday about IOU ring and Samba moving to this for async IO. Just looking at some, from a few years ago, here's some syscalls that were added for the file system layer. We have to keep up with this. So it's something that's going to, it's a moving target, right? We can't just stop. And our goal is to make this as easy and transparent as possible. You don't want users to know whether they're running remotely or locally. As Linux evolves, we need to be able to quickly add these things. Now, the nice thing about SMB3.1.1 is it's very easy to add new open context, new flags, and new negotiate context. So this shouldn't be, adding new FSCTLs. These kind of things shouldn't be hard in theory, but we're going to have to get in that mode over the next few years now that POSIX extensions are available in multiple servers and multiple clients. Now, so why do we talk about SMB instead of other protocols? Well, I could bring up some examples from the File System Summit a few years ago where people were arguing about RDMA and memory mapping and various bugs, and the file system people are all wondering, why are you worried about that data corruption? You're supposed to use a file system. That's what file systems are for, so you can share things across multiple machines without corrupting your data. There are a few alternatives, but SMB3.1.1 is the broadest implemented, right, from Macs to embedded devices to Linux to Windows, servers like Azure in the cloud, and many servers like Samba. And if you look at SMB, it's also part of a huge family of protocols which can do more than any other family of file system protocols. And it's got this incredible set of test cases, not just SMB Torture, which many of you are familiar with, but there are also test cases um, that Microsoft and others have written, and the documentation is exhaustive. It's also proven across such a wide variety of architectures, OS, and client types. And of course, we've done POSIX extensions before for SMB1. And don't forget Samba, right? You have multiple open server choices, ksmbd and Samba, but Samba is huge, over 3 million lines of code. And of course, on the Linux kernel side, sys.ko is one of the most active file systems. It's the most active of the network and cluster file systems in terms of change sets. So why do we need extensions? Well, the simple answer is the file semantics, the default for SMB2 and later were based on Windows, which differs from POSIX and Linux in a few ways. And we don't want people using the SMB1, the old SIFS Unix extensions, which have been around for, they were started to be implemented a long time ago. And, they're very popular in the 90s, but, not something that, that you want to do in today's world with security challenges. So, as we move away from old insecure dialects, we're at SMB3.1.1. It's fast, it's more secure, it's simpler, it's better, but we need POSIX extensions for that. So one of the things that have been holding us back for a long time is the progress on the Samba side, the Samba server side. We implemented them experimentally on the client to other servers like ksmbd, but now that Samba has made such good progress recently, this is a very exciting time. Note that the SMB3.1.1 POSIX extensions are much simpler than the old SIFS Unix extensions, and they're intended to completely replace any use case for the SMB1 or SIFS Unix extensions. Now, let's talk about what works today without POSIX extensions. Normal file and directory operations work to all servers without POSIX, right? You can open a file, read a file, sync, write, close. Hard links work. You can even have safe client-handled symlinks, the Minshall French symlinks that Apple clients and Linux often use. You can preserve case it'll preserve whether it's uppercase or lowercase for most servers, most file systems. Most problematic characters like backslash can be, well, everything except backslash can be mapped, but problematic characters can be mapped pretty well. So most servers support sparse file operations, query allocated ranges, punch hole, clone, copy. Clone range is less common than copy range, but even many servers support that as well. And special files were often handled via reparse points. Remember the good old days of something called SFU, or services for Unix, that some servers implemented? And extended attributes are supported by most servers. So even without POSIX extension, there's a lot of really cool features that go outside the scope of what you think of as traditional Windows. Windows applications can use these as well. And then there's ways to emulate mode bits via various alternatives. The mode from SID and syscalls allows you to, you can look up the ACL and emulate the mode bits from the rich ACL, the NTFS SMB ACL. So you can emulate a lot of these Linux extensions, these newer things, the various fallocate calls, fcollapse, and finsert. You can emulate many of them without POSIX extensions. Most delete and rename scenarios can be done. There are some exceptions where the rename fails with an access denied, renaming onto an existing file, for example. Most byte range lock scenarios can be emulated. Now they're easier with what's called OFD locks. Jeff Layton, a man well known to many of the Samba team, developed this alternative to POSIX byte range locks, which are kind of broken by design, called OFD locks that are often used by Linux applications. And most byte range lock and whole file lock scenarios can be emulated okay. And even special mode bits like the sticky bit can be emulated without POSIX extension. But there's a lot of problems with that. POSIX app expect case-sensitive file and directory names. They expect primitive mode bits to be returned, not just the rich ACL. They want those 0777 perms to be able to be displayed accurately. They want to be able to delete open files, and when you delete an open file, they don't want a reader to see it. They want to be able to rename an open file. They want to be able to deal with advisory rather than mandatory byte range locks. And then there's minor differences like statfs, for example, in returns two additional fields, the total inodes and free inodes that can't be returned by a traditional query file system info call. But the obvious question then to ask is what happens if POSIX and Windows clients are accessing the same file? What if the semantics collide? The good news about that is that Samba learned a lot of lessons from doing the exact same thing with the CIFS, the SMB1 Unix extensions. So many of these are known problems. Now, what about rich ACLs and mode bits? This is a long-standing thing that many are familiar with. ksmbd supports this. Samba is currently it disables the most of the rich ACL stuff when you have the POSIX extension supported on a share. But this is an interesting question because it's come around a long time, and the good news is we've had a lot of practice with this. Many file systems over the years have dealt with this and still do deal with this. So these are well understood problems. It's not something new that we have to invent. Now, the obvious question people might ask is, what about Apple? Apple has extensions, and Apple is kind of Unix-like. So what about its Mac extensions to SMB3.1.1, the AAPL context, for example? The problem was it only addresses part of what Linux needs. Now, that solves a subset of problems, and you can see this. At some point we ought to implement the AAPL context. Apple is supported by Samba, right? Samba has a VFS fruit module. Adds other interesting features like Spotlight integration. And this does solve some of the key problems you can see here, case sensitivity, and but it's not all the problems. And that's, our goal here is to emulate Linux really well, not just a little partial thing. So how could you try the POSIX extensions today? Well, one way is just get a Linux kernel client that's relatively new. And the good news is that, this my typical test machines, I'm running Ubuntu and or some version of Red Hat or SUSE. And many of these make it very easy to install the a recent kernel, even if you're running an older kernel on that. From the 5.8 kernel on, you're able to do some experiments, but newer versions of Samba's SMB client also support this, thanks to Volker. And server include ksmbd, thank you to Namjay and others. And Jeremy, Volker, David, and others have done a great job improving the Samba server recently. And then at the SMB Flugfest, we also tested some other implementations last fall. So let's talk about some examples of where they're needed. Here's a great example. So if you look at case sensitivity as an example. So here we've created a file on Samba, a set of files, and we're mounting without POSIX. And you have case sensitive example. You have 3 different case sensitive examples with different cases. Notice that no matter which one I try to open, I get the exact same. So basically it's choosing to open one of those three, even though all three differ in size. So one of them is 19 bytes, one's 6 bytes, one's 11 bytes, and we're returning the 11 byte one. So it's a great example of you could lose data here, right? You could have two files with the same name. You think you're opening one of them, and you're actually opening another. The server, in this case Samba, could report all those files in that directory, even though they have similar names, just differing in case, but it can't allow you to open the correct one. It's going to, in this case, it's opening the 11 byte one, but you can't get at the 6 byte or the 19 byte one. So this is a great, easy example that anybody can see. And then the question is, well, how could we develop an answer for this that's simple? Well, we went forward with an approach, 4 or 5 years ago that was the simplest. We have just a single negotiate context, and it can be extended to add new version information, and an open context, and a new file info level, and a new FS info level. And everything else relies on existing SMB3.1.1 features that were already there. So let's give some examples to Samba and also to the kernel server ksmbd using these POSIX extensions. Now, setting up Samba and ksmb shares are easy. Samba requires setting this SMB3 Unix extensions equals yes in SMBconf. And here you can see an example on the left of a Samba SMBconf and on the right of a ksmbd SMBconf. Notice that ksmbd tried to use similar syntax for its conf file to make it less confusing, similar to Samba. Now, here's some additional advice when you're trying to configure Samba. Build Samba with configure developer, because these features were only available, at least last I tried, you had to have configure developer run before you built Samba. And if you're going to report mode bits, you have to disable ACL-XAdder if you have that in your VFS objects for that share. Also, you might consider relaxing the create mask. SMBconf has parameters called create mask and directory mask that are optional, but these setting these prevent the server from modifying the mode bits that you specify on create, excuse me. Now, when you mount from the Linux kernel, it's very easy. All you have to do is add one parm, POSIX, on the mount command. You may also want to consider MF symlinks. Currently, MF symlinks may be an easier way to handle symlinks for multiple reasons. One, since they're evaluated only on the client, there's less security risk of the server following them accidentally. So many people choose to mount with MF symlinks. But to get the POSIX extensions, all you need is that one extra mount parm, POSIX. So it can display, when you mount with POSIX, you can display owner and mode bits. And notice the bug in the group owner versus user owner in this slide, which was fixed in the following slide. Now, note that the exact mode bits and owner are reported with the POSIX extensions. Here's a Wireshark trace showing the owner SID being returned. And you can see an example of LS here, LS of a file that is owned by test user 1 and LS of and you also see root owns smalldir. So we're returning the exact ownership information, and notice we're also returning the mode bits properly. This example is to ksmbd. And notice also query fsinfo. I've highlighted, and you can see in yellow here, the two fields, total inodes and free inodes, which were not available to be displayed without POSIX extensions. So query fsinfo now works. Now what's very exciting is that the same thing works to Samba. So you can see the same example. I have 3 shares mounted here, the local share, then 2 SMB shares. Notice I'm mounted here with SMB3, but you can mount with SIFs and get the same results. I've mounted with the POSIX extensions in the share that's /mount/POSIX, and without POSIX in the /mount/non-POSIX. So if you look at the results of stat-f, you can see that we accurately report all of the data when you mount with POSIX extensions, a significant improvement. So here's another example. Here's a local on the left. So this is the local files in Linux on the left. And here's Samba exporting them by default without POSIX on the right. And I think you can see some big problems here. One problem is that the mode bits all show up as 755. That's the default. I mean, if you mounted with 777, file mode or dir mode, you'd see that. But all of them will have exactly the same owner. All of them will have exactly the same mode. Now you can do games like ID from SID and mode from SID, and you can see slightly different values depending on the ACL. Or you can mount with syscalls and get the best guess as to the permissions based on the ACL. But notice that by default, normal SMB mount, you don't have the right owner, you don't have the right mode bits. It's also hard because it's not showing you, the only special files you see show up are MF symlinks. You can see MF symlink source to target there. If you look down there, you can see this file, this is FIFO, just shows up as a regular file. And of course, if we tried to open upper, that file, the 3 files, the different case named upper, it would be random what we get. And now, by contrast, let's take a look at the local mount on the left and a POSIX mount on the right. So this is going to Samba, just like the last slide. Notice the bug in the upper right corner, the cannot access mount POSIX source. That's because of symlink following. Samba is still in process on working on symlink stuff, and there may be some emulation we can do to fix that. And you can notice in the native symlink example that says source all the way down near the bottom on the right, it shows up as question mark. Samba currently doesn't support reparse points yet to display special files. So this is FIFO. Doesn't display properly in the Samba example yet. So that still shows as a file. But notice the ownership information and the mode bits look correct with some minor exceptions. You're seeing that in this particular example, I'm able to map the group, but I'm not able to map the test user 1 owner field. So that's something we still need to work on and set up configuration to make it a little bit easier for users to see that properly. But this is a huge improvement. We're seeing mode bits accurately, we're seeing mostly owner accurately, and we're able to display even special mode bits like in the slide we just saw, we have like the sticky bit on a directory can be shown. And also notice that we've even improved performance of this. We now do compounding. So before it used to be a create, get info, close. Now it's one request compounded sent together to return this information. To give you some details on what you're going to see, here is an example of a Wireshark trace of using the POSIX extensions. Notice that we have a negotiate context you can see on the right. That negotiate context is very simple, but it requests the server to respond whether it supports the POSIX extensions. Now there's additional information on these extensions that you can find at this wiki here in this slide, and you can also find details on the older SMB1 extensions there and an older SNIA document. Now the negotiate protocol context returns or sends a field, this POSIX reserve field, that indicates that it supports POSIX. And then it gets a response from the server indicating that POSIX extensions are supported. And on the open call, a POSIX create context is sent, and the POSIX create context, you can see an example of it on the right-hand side of the screen here. You can see it includes the permissions. Now, what's next? Because obviously the goal is not to support Linux from 5 years ago. The goal is to continue to support Linux well as it continues to evolve. And there are clearly missing features that we want to, as Samba is now supporting these extensions, we want to add. But the obvious thing is to examine the file system test. XFS test is the standardized set of file system functional tests. And we go through it one by one, all the skips, all the failures in a lot of detail, and add small incremental changes. Now, a few things are important to understand about XFS test. It's the standard Linux file system functional test suite, and there's no one file system passes all these tests, and that's due to various file system optional features. Now, some of these can be emulated. Some of these missing features can be emulated, and some would need new flags or new FSCTLs. Now, if that's not possible, we might consider adding a new POSIX extensions version, which would be, adding another UUID to the POSIX negotiate context. And then we could have a new POSIX open context that we can send to get these new features. But, we ought to also think about performance, because Linux workloads are very chatty compared to Windows. If you look at, a local file system or any network file system, it gets annoying that Linux constantly is revalidating every component of a long directory. You could have /dir1, /dir2, /dir3, on and on and on subdirectories that you have to revalidate before you open the file that you're trying to open. And those revalidate requests can be expensive because each one of those is sent individually to the file system. So we have to think about examples of how do we make this faster? And other examples could include things like fallocate. There are various options in fallocate, like collapse and insert, but what if we treated them as a single operation instead of today where we kind of do this, we emulate it via a couple operations on the wire. So it's great that we can take advantage of things like duplicate extents, but it might be better if we could take advantage of these NTFS FSCTLs that, as far as I know, are not exposed over SMB today, like shuffle file and rearrange file. Just exposing those FSCTLs might be enough to improve the performance and make safer some of these fallocate options. And we've also thought about, what would happen if we just expose Windows file flag POSIX semantics flag? And of course, in SMB generally, the more compounding, the better. There was an example somebody gave recently that when you're listing a directory, you ought to not just send the open for the directory and the query dir, but you ought to send a second query dir, because in most cases, the second query dir is going to return no more files. So it'll save you a round trip to improve your compounding there. There's hundreds of examples I'm sure we'll find like that where additional compounding can help. Now, another example that came up recently was rename swap or rename exchange. There are examples in XFS tests where those tests are skipped because network file systems don't typically support switching. If you want to rename file A to B and swap them, so B gets named A and A gets named B, support for that isn't available in most network file systems. Maybe it would be an easy FSCTL to add to SMB. And now that we have multiple servers, not just Samba, not just ksmbd, it makes it easier to imagine adding these features easily, testing them out, and then going into production with those, which would allow us to run more XFS tests and also more safely support an even broader set of workloads. Now, one of the things that I think is a topic of another talk that Volker is doing is improving server-side symlink handling. When you have client-only symlinks, like MF symlinks, this isn't an issue. But to support server-side symlinks, it relies on the server supporting reparse points to report symlinks. Now, this can be improved by simply improving the handling of stopped on symlink error, which does include sufficient information in most cases to avoid needing to query reparse points. But as you saw from that earlier slide, today we still have some work to do to improve that example of server-side symlinks, and Samba also needs to be able to support reparse points to better able to report these symlinks. Now, what's really interesting to me about all this too is that simple, I mean, these aren't common, but FIFOs, carrier devices, block devices, these are also reported as reparse points, but Samba currently doesn't support that. When Samba does support that, we'll be able to much better do things like booting off SMB on, let's say, a diskless system. So these are kind of exciting things. There's other features that, although not directly related to POSIX, are going to be also very exciting to add. Linux, in theory, would allow you to swap over SMB, and we used to support that, but changes to the VFS layer last year caused that to be disabled. If you could boot from a diskless system, we add these additional features for special files. You can swap over a network file system. This becomes even more powerful. So I do recommend you follow up on Volker's talk to get more information about the changes going on to Samba for symlink support. Now, let's give a couple examples from deep dives into XFS tests, and many of these things are also available on in the Samba wiki in the XFS test section. So we need to add support at some point for rename at2 and rename exchange. At some point, we have to figure out whether we want to emulate POSIX ACLs. As you probably know, POSIX ACLs are a subset of rich ACLs. There had been pushback in the Linux kernel community on implementing rich ACLs, but there are a few file systems that do support that, not just SMB. But there's also been some pushback on implementing these primitive POSIX ACLs in the SMB3.1.1 POSIX extensions. And maybe what we just do is report the POSIX ACLs the best case we can, right? Because clearly we already know how to query ACLs, and querying the rich ACLs and mapping them to POSIX ACLs is doable. What about supporting additional CH adder flags? Some of the test cases, some of the XFS tests are failed today because we don't have a trivial way of setting something as immutable. I mean, there is an ACL entry, an ACE we could set for that. And then certain things like no A time. There's various CH adder flags, though. We have to investigate one by one and see if any of these require changes to the POSIX extension. Looking at how collapse range is handled is another example. How we would handle the dedupe API internally in the Linux kernel. Could we send that over the wire? Could we support defragmentation, or do we need to change the VFS? There was some very exciting progress last year as a result of our presentations at the Linux File System Summit a year ago. We were able to get the file system developers to agree to extend the Linux API to make it possible to do temp files over SMB. And there's also discussion about how to re-enable notify support. iNotify support was originally developed for SMB, but today only supports local file systems. And it's kind of an exciting thing to, as we go forward, to see these minor changes to the VFS layer that will allow us to support a broader range of Linux APIs remotely. So here are some other examples from XFS test investigation. Rich ACL support lack of it causes 9 tests to fail, or skipped actually, not fail. OTemp file support, as I mentioned, is emulatable now, and the VFS changes look like they would work, and Fuse and I think one other file system do support it now, so it's something I can add support for. So the trim support may be emulatable. Quota support, we don't know if it's emulatable or not yet. Support for native Linux quotas API. One of the other interesting examples is, and we used to play around with this a little bit years ago, was exporting NFS over an SMB mount. Now the reverse has been done, obviously exporting Samba running over an NFS mount, but getting NFS server to run on an SMB mount may be a more secure alternative for some workloads and may have some advantages, but there's one feature needed for that. Also, what about case-sensitive X adders? That's some of the test cases require that. And then another thing that comes up a lot, people ask about is as features like landlock and SE Linux support. There is an NFS RFC for basically doing a subset of SE Linux over NFS 4.2. So could we do something like this to Samba and ksmbd by adding minor protocol extensions for this, similar to what NFS did? And another example is online label manipulation. See, and here's an example, generic 492. Another example is chadder plus F, the case folding. And then an obvious question, would native rather than emulated whole file lock support? Today, whole file locks, BSD style F locks, are handled by basically locking the whole file with a byte range lock. Would it help to have a BSD style whole file lock API? Probably not, but these are worth considering. Here's another example. Temp files required for test 4, defragmentation required for test 18, rename at2 for test 25, POSIX Extensions for 26, trim for 38, metadata journaling for 49. And here's an article about the freezing FSCTL if you guys want to dive into some more information. LWN has some fantastic information on the file system layering. So test 68 requires this new FSCTL for freezing. Well, could we do something like that with a minor extension to SMB3.1.1? chadder examples here for test 79 and 277. Then some examples of disk quotas and dedupe and advisory locks. These are all test case numbers in parentheses here from XFS test, the standard functional test suite for file systems. So here's some examples of additional detail. Being able to return the timestamp bounds from the server. That sounds like an easy FSCTL or query info. We have to be able to do an open by inode number if we want to support NFS exports. There is one test case, test 453, that requires support for a backslash and a name. We could support encryption. We already support it over the wire, and we have an attribute flag we can set for it to encrypt at rest. But test 395 only require minor changes to support that. What about xadder replace? What about xadders that have slashes in their name? Or case folding support? Or support for Verity? Here are examples of specific tests that would require only very minor extensions to support. So this is a very exciting time. There's lots of really cool features in the POSIX extensions, but the message I want to leave you with is I want you guys to continue to test and use the POSIX extensions now that Samba has support for it. And it's also excellent because you can compare two servers. You can compare the behavior of ksmbd as a server and Samba. You can compare the behavior of two clients. You can compare, for example, SMB client with sys.ko, the Linux kernel client. That allows us to continue to make progress, find any additional bugs or features, fix them. But it also allows us to get a better feel for how easy it would be to extend this to support more and more use cases. And I want us to be open to adding FSCTL calls and adding new info levels if necessary. I think in many cases these would be quite easy to do. And that would allow us to one by one gradually improve the ability for network file systems, for SMB, to support the widest variety of workloads imaginable. And in the long run, I don't think there's any particular reason why network file systems shouldn't be able to support everything that a local file system can. Because, if you think about a file system, it's a superset of what block devices do. It's a superset of what blobs do. And legacy applications, new applications, and old applications do not have to be rewritten if we carefully support all of these features in a way that makes a local file system and a network file system behave similarly and allow us to support Linux behavior accurately to the widest variety of servers. So I encourage you guys to follow up on this. The Linux CIFS mailing list has a lot of useful information, as does Samba Technical, and I look forward to hearing your feedback. And also, please feel free to help with any patches or testing that you want, or report bugs on this. And we're going to be hopefully talking about this next year as Samba rolls out even better support for the POSIX extensions. But in the meantime, there are workloads already that would benefit from this. So please go ahead and try this, and thank you for your time.